Lesson 6. The composite of a box and a wedge. Here's a box. This box has a surface area that is already known. It's given at 300 centimeters squared. I don't want to look at all the dimensions of the box, but I would like to look at the height, which is 8 centimeters, and the base, which is 7 centimeters. Now let's set that aside and look at a wedge. Here's the wedge. It also has a surface area that's known. It's 200 centimeters squared, let's say. And there is one face of the wedge that is known as well. It has a line across the top there of 7 centimeters and also a height of 8 centimeters, which you might notice balances or matches the box exactly. Well, let's think about putting them together. If we do, some of what is on the outside of the wedge and on the outside of the box will disappear inside the new object called a composite. Let's put them together, shall we? Here it is. Now I'll just fix that drawing up a little. There we go. Here is the question. What is the surface area of the composite of the box and the wedge? I can say one thing. It has to be less than 300 plus 200 because some of what was on the outside is now on the inside. The part of the surface area that we have lost is the area of contact. The area of contact can be found simply by looking at the two shapes 8 by 7. 54 centimeters squared. Now it's lost from both objects. What I mean by that is that the box, which started at 300 centimeters squared, loses 54 centimeters squared. But the wedge, which started at 200 centimeters squared, also loses 54 centimeters squared. Both faces went missing when we glued them together. Well, they're not missing, they're inside. And the surface area of the composite, the single object that is formed, is 246 from the box and 146 from what's left of the wedge to give a new surface area of 392 centimeters squared. Well, I'd like to make a little bit more room because I want to have one more thing to look at here. It's the net. What is the net of this composite object? Clearly, the part that is in contact when we glue them together, that's no longer part of the outside. So if we take the blue base there, that's a rectangle. Let's begin our net there. And then the far side of the new object, which I'm shading in here in red, let's flip that down, and it's joined to the rectangle that is blue, of course. And in fact, if we keep working our way around, the top of the wedge here, shown in this color, also flips down. And there it is. They're all connected. Notice that they're all the same width. There's one more piece that's the same width. Let's flop the rest of it down. There is the slope and the two wings of the wedge all together. Let's mark equal sides. In blue, we have the top, which matches certain other parts, also marked in blue. The slope has to match in two places. This has to be able to fold up into a wedge. Let me just change those blue markings to make it 3, just so that they're different from the green markings. Those are all the same, and all the widths are the same all the way along this net. Well, the net is now complete. Using rectangles and triangles, you could find the surface area. That's it.